Alright, let's take a look at question 7. In question 7, you're being assessed on how to verify if factors are roots of a polynomial using the factor theorem. Okay? Question 7 reads, given p of x equals x to the third minus 3x squared minus 2x plus 4, which statement is true? So we have 4 statements here. Okay, we have the factors and we have the implied roots based on what the factors are. Okay, so before we start writing down the solving the problem, let's go ahead and note what the factor theorem is. Okay, so if you know what the factor theorem is, then you are in a good position to solve the problem. Alright, so the factor theorem is as follows. If x minus a, okay, if x minus a is a factor of some polynomial, let's say f of x, or let's put it this way, x minus a is a factor of f of x if and only if and only if f of the related root for that polynomial factor, which is a, is equal to 0. Okay, so that's your factor theorem right there. So we're going to be using this factor theorem to go through the problems. Alrighty, so let's take a look at the factor theorem first, and then let's take a look at the options that we have. So factor theorem says if you plug in the related roots to the factor, you're going to get 0. Take a look at the 4 options that we have here. Which of them involves plugging in a root into a polynomial and getting 0? Options 3 and 4 meet that criteria. If you look at option 1 and 2, it's being plugged, you're getting 2 as an output. This does not match up with the factor theorem. Okay, it doesn't satisfy the conclusion of the factor theorem. So we automatically eliminate option 1 and 2 because those 2 statements do not tell you if a polynomial factor is a factor of a polynomial. Okay, alright. Now, option 3 and 4 look more like this. Okay, x plus 1 is a factor because p of 1 equals 0, and x minus 1 is a factor because p of 1 equals 0. So these two harmonize with the factor theorem because they've been set equal to 0. So the question is, which one of them is incorrect? The problem should be connected with this piece right here, p of 1. Both of them are using p of 1. So is that always the case? Does it matter what you plug in? Well, it certainly does. So what we're going to do is we're just going to go ahead and test both of them out and see which one actually works. Okay, so using the factor theorem, we're going to test the first factor, x plus 1. Is this a factor? Well, to do that, what you do is you find the related root. Set x plus 1 equal to 0. Okay, so when you solve this, you subtract 1 from both sides. You have x equals negative 1. Okay, so x equals negative 1. Now we're going to plug in negative 1. We have to find if p of negative 1 is equal to 0. Hold on, wait a minute. This says, check, this says p of 1, and this is p of negative 1. Do you see the problem here? The related root for x plus 1 is negative 1. X plus 1 tells us if p of negative 1 is a root. X plus 1 does not tell us if p of 1 is a root. Okay, so based on that alone, we can automatically eliminate option 3. The answer should be option 4. Okay, so let's just show you how that works. So for option 4, we want to test x minus 1. Okay, so to do that, you say x minus 1 equal to 0. You solve it for x. X equals 1. You add 1 to both sides. Okay, and then we're going to test to see if the polynomial evaluated at 1 is equal to 0. Okay, so let's do it. P of x is x to the third minus 3x squared minus 2x plus 4. So p of 1 simply means we substitute all the x's with 1. So we have 1 to the third minus 3 times 1 squared minus 2 times 1 plus 4. Okay, we're just going to PEMDAS this real quick. Do the exponents first. 1 minus 3 minus 2 plus 4 minus 1 minus 3 is negative 2 minus 2 plus 4 is positive 2 equals 0. Bam! Excellent. We can see that option number 4 is the correct answer, because if x minus 1 is a factor, based on the factor theorem, x minus 1 is a factor if and only if what? Its related root, which is what you get when you set is equal to 0 and solve p of 1 is equal to 0. So option 4 is the only correct statement that matches with the factor theorem correctly. Time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your preparation for your upcoming Algebra 2 Regents exam, do give us a thumbs up. Your positive feedback is extremely important to us. If you have any questions or comments or special requests, just post it in the comment section below and we'll be more than glad to respond. Do not forget to subscribe to our channel for updates to the remainder of this review series and all the great math resources to help you master Algebra 2 and beyond. More support resources from Algebra to Calculus can be found on our website at Mathgotserved.com. Do check it out. Thanks again for watching and have a wonderful day. Goodbye.